A rocket is launched from rest at x equal to 0 and follows a parabolic flight path described by y squared equals to 7500x, where x and y are measured in meters. The rocket's horizontal acceleration is given by a sub x equal to 3/4 of t squared, where ax is in meters per second squared and t is measured in seconds. What is the magnitude of the rocket's velocity when t is equal to 10 seconds? Try solving this problem yourself before watching the solution to make the most out of this example. This is the second example for the curvilinear motion in Cartesian coordinates 11-minute video. The links to the other examples on this topic and the other lectures of the dynamics course are found in the description below. The problem is asking for the magnitude of the rocket's velocity. That just means the speed, which can be written in terms of vx and vy. Since we have the acceleration in x, it's easy to see that we can find vx if we integrate with respect to time once. The limits here are 0 speed at t equal to 0, because the problem states that the rocket is launched from rest, and the upper limits are velocity and time t. We substitute ax and integrate, find vx, and since the speed we're looking for is at t equal to 10 seconds, we substitute and find that vx is 250 meters per second. Now for vy, we can do what we did in the previous problem, which is differentiate the path equation to get a v sub y term, or we can try to find an equation for v sub y in terms of time, so that all we have to do there is substitute t for 10 seconds. Let's do the latter to practice different methods. Since we have an equation that relates x and y, it means that if we have x in terms of time, we will have y in terms of time. And if we have y in terms of time, we also have vy in terms of time, which is what we're trying to find. So first step, find x in terms of time. This is achieved by integrating v sub x. Again, the lower limits are 0 because the rocket is launched from x equal to 0, and the upper limits are position x and time t. With this, we substitute x in the path equation, and we get an equation for y in terms of time. And now all we do is differentiate y with respect to t to get vy. We substitute t equal to 10 seconds, and we find vy to be 433 meters per second. We plug in these two velocity components in our speed expression, and find the speed to be 500 meters per second. Notice that using this method, we didn't have to calculate the intermediate values x and y that we would otherwise have to calculate if we had used the first method I mentioned. If you want to check out other examples in this curvilinear motion and Cartesian coordinates topic, the main lecture video or other lectures of the dynamics course and other engineering courses, make sure to check out the links in the description below. Thanks for watching.